Hello everyone. In this presentation, I would like to talk about the wine quality analysis using machine learning. In this presentation, we are considering wine ingredients, and in the following, we will call them wine features. Uh, to Based on these features, we can predict the wine quality, the red wine quality based on these features and ingredients. Uh, the objectives of the project is the main object is to predict the red wine quality using machine learning by Python programming. And a data set is provided by UCI machine learning repository. Is it analyzed, and wine quality is modeled to show wine quality dependency on different parameters such as alcohol and citric acid and etc. The wine quality dependency on these parameters are analyzed using machine learning algorithm such as a random forest and decision tree algorithm. Uh, Here is the architecture of the software that is used in this project. We have an input as our data set, which has all the wine ingredients, and has a column which is wine quality. The score of that column is from 3 to 8. So we have this data set as an input, and we split this data set to test data and training data for the modeling, and uh, test set data for the evaluating of our model accuracy actually. And then after that we apply our model in our training data, and then we get the output. If the model and the data if the data set needs tuning, we apply tuning to our data set. In the in the following slides, I'm going to explain about how we tune the data. We did a very basic tuning in this project. The data set and the values of the some data are really outlined, and they're going to affect the model accuracy. So we get rid of those outline data, and we replace them with the mean of that specific feature of the wine quality. And in the following next slide, I walk you through that. Uh, then, as I mentioned in previous slide, these are all the features and the ingredients I was talking about. Uh, Wine has these different ingredients. The red wine has different ingredients, such as citric acid, volatile acidity, alcohol, uh, density, pH, and etc. Each one of these ingredients has its own impact on on wine quality. But we not looking into each one of them. We want to see which one of these features has the most positive effect and has the most positive correlation with wine quality. And we're gonna, after analyzing of the data set, we're gonna see which one has the most and extract those features, see which one has the most effect. Uh, This is the data analysis that it's applied in our wine quality data set. To understand the characteristics of the wine and find ingredients contributing more for quality, the following is implemented. We subset the data on good quality and bad quality. We score the good quality of the wine. The wine that has the score of 7 or 8 are considered as good quality, wine with good quality. And the wine that has a score of 3 to 7 um, has the bad quality. It's considered as bad quality, wine with the bad quality. Later on, we just, as I mentioned, we just assign the digit 1 to the ones that has a good quality, and digit 0 to the one that has a bad quality. Later on, I'll walk you through that one as well. And then finding the most correlated wine ingredients, as I mentioned before in the previous slide, to wine quality using heat map or correlation matrix. So we using correlation matrix, we will see which ingredients has the most impact, most positive impact, and was most correlated with the wine quality. And then we model the data, say the training data, by a random forest classifier, and we model it also with decision tree. Then we do a comparison between these two machine learning algorithm, see which accuracy of this machine learning algorithm, compare the accuracy, and we kind of prove that why random forest classifier is better for this project and has more better accuracy. Then we tune the dataset to achieve higher model accuracy. As I mentioned in previous slides, this is the graph that shows the quality of the wine. As we know, the data is very is kind of distributed mostly between 5 and 6. The wine quality score is between distributed between 5 and 6, and then we consider but from 3 to 6 as a from 3 to 6 as a bad quality, and 7 to 8 as good quality wine. And then in the following, we show you how we are considering these numbers. For the pre-processing, we drop quality of the wine column, which is ranged from 3 to 8, and then binarize it to 0 and 1, as I mentioned. 0 represent wines with a good bad quality that are less than 7, and 1 represent the wine with good quality that are bigger or equal to 7. Here's the data set. Actually, the data description shows you that this is the number of the data that we have, like almost I would say 1598 of wine samples we have here, and this is the quality of the wine in the last column. And we drop this one because then we're gonna use this one, and and then we're gonna train this data again to predict the quality of the wine using the ingredients of it. And here, this column is actually quality of the wine here in this the latest one, the latest screenshot, which we assign 0 and 1 to wine quality. As I said, 3 to 7 is 0, and 7 and 8 is 1 as a good quality, wine with a good quality. Next step, we want to see, after we did that, we want to see which ingredients has the most positive effect or most correlation with wine quality. By that, we used correlation matrix or heat map. With correlation matrix, we can see which ingredients, which features has the most correlation with wine quality. As we see here, as the color gets lighter, it has more correlation with quality. In this heat map here, we see that in the alcohol and sulfates and citric acid has the most correlation with wine quality. Alcohol is 0.48, and sulfates it's 0.25, and citric acid is the 0.23. These are these three numbers are the biggest numbers among other ingredients numbers. So we consider these three features that has the most correlation with wine quality. We also using density bar to prove or claim by saying that what we can see is citric acid. As citric acid gets increased, the quality of wine here gets increased. Also alcohol, as it gets increased, the quality of the wine gets increased. As I mentioned, sulfates here, as it gets increased, the quality of wine gets increased. So these three features ingredients has the most correlation with wine quality. And then after that, we are going to train our data and apply random forest to our training data, and then we want to predict predict the model accuracy, and then we can test our data, see how accurate our model is. So we perform a split operation on our data set in order to train machine learning model for wine quality and evaluate their accuracies. Or test size of the data is a 20% of the whole data set that we consider in this project here. And here we apply two machine learning algorithm to our training data, and after we applied that, we see how accurate our model is, and then we can see that random forest classifier algorithm has a better accuracy than a random decision tree, which makes sense because as we know, a tree is basically a flowchart of yes or no questions, right? Decision trees are easy to read and understand and can model human decision process. But however, they don't have the best accuracy. They are hard to train and they are unstable in changes in the data. Whereas random forest improve prediction performance over decision trees by averaging multiple decision trees. The algorithm creates several random subsets of the original data, in this case the training set, and calculates the decision trees. Then the final result is the average of all trees. So it makes sense that random forest classifier has the better accuracy than decision tree. As I mentioned in previous slides, we have some data, that some outline data that it's going to affect our model accuracy. The way we did tuning, we tuned the data was that we got rid of those outline data, and then we replaced them with the mean of the data in that category. And after replacing them, and after getting rid of this outline data here, so like example, like this citric acid has this outliner data, see how the range is really spread with other data. Or here for this for sugar, we have too many outline data that we gotta get rid of them. Actually, we replace them with the mean number of that data for that category. And as we can see, after the tuning of the data, we see that the model accuracy is increased to 0.93 for random forest, and for random decision trees increased by 0.89 compared to not tuned data, which is 0.92, and for decision trees 88. So we see that tuning has a positive impact on our model accuracy. As conclusion, random forest classifier has a better model accuracy for wine quality, and also by tuning the data set, the model accuracy is improved. Thank you so much.